Hello guys, welcome to the new video. In this video, we are going to discuss uh, we are going to revise, I think. Let's go to 45 minutes of lecture. Right, so, alright, so this lecture would be of, this lecture is for discrete mathematics revision, alright? So, what is it? Revision, revise, revision, discrete mathematics, alright. So, first we would start from logic. Right, this is a topic logic. Logic is, you have already heard about this. Logic is a decision, right, in two forms, yes or no, or we can say true or false, or 1 or 0, plus, minus, like that. All right, so this is logic. So first topic is in this is proposition. Proposition is what? Any declarative statement which is either true or false. Alright, so proposition is any declarative statement which is either false or true. Oh, which is either false or true. But it can't be both, right? But it can't be both. So what we are doing, we are giving a decision at any point of time. It could, this that decision could be false or true. All right. So let's say we are saying that Amit is tall. Let's say Amit is tall. This is its statement. Right? Amit could be, this is a declaration in itself. So Amit could be tall in comparison to others, or it can be short. Amit can be short in comparison to different people. So, but we are declaring Amit as tall. So it could be true or false, doesn't matter. All right. But we are declaring Amit is a specific person. But if we are saying he is tall, so what is he here? This is not a declarative statement. This is ambiguous. There is ambiguity. There is ambiguity in this. So to taking the decision. So who is he in this? So this is ambiguous. He is ambiguous. So we cannot say, we cannot declare about he only. All right. So what we are saying that if let's say there are two people, one is Rahul, one is Sonu, and one is, let's say, Syam. Syam is 4 foot, Rahul is 3 foot, Sonu is 5 foot. Let's say. So I am saying Syam as he. So Syam is tall. Yes, Syam is tall in comparison to what? Rahul. But if I am saying he for Rahul, so So Rahul is not tall in comparison to both Syam and Sonu. So this is false here, yes. But if we are putting he, uh, we can say what we are saying is, let's say Syam. Here is Syam. We are comparing he to Syam. So if he is Rahul, then it is false. If he is Sonu, then it is true in comparison to Syam. So what we are saying is, this is ambiguous for one he only. For one he only, uh, on comparison with Syam. Right? So this can't be done. Alright? So this is ambiguous here. Declarative statement are only, uh, we are we are saying that, preposition. Right? So hope you understand what is declarative statement, and let's discuss. Let's say one example is 7 plus 3 is, let's say, 5 only. So this is false logically, alright? But it is true. But there is a preposition. It is also preposition, alright? This is preposition. But if we are saying 7 plus x is 5, then there is a variable. There is ambiguity here, alright? So this is not a preposition, not a preposition. So next topic is next topic is here is, what is a liar paradox? Liar paradox is what? When a statement refers to itself and creates a self contradiction. So it's a liar paradox. So what are I'm saying is, there are, if a statement, it could be any statement, when a statement refers to itself that creates a self-referential contradiction, then it is liar paradox. For example, let's say I am lying. This statement is itself a liar paradox. Alright? How? If I am lying, it is true. So logically, I am not lying. But I am declaring that I am lying. So logically, I am not lying, but if it is true, but I am declaring that I am lying. So both are contradicting to, for it, for self-contradicting statements, both of them, right? I am not lying and I am lying. Both are coming. So liar paradoxes are not preposition, not a preposition. All right. So we can change this color to blue also. Right. So these are not preposition. And if it false, if it is false, we can say, let's say it is false. Then I am lying is true logically, but at conceptually, or at declarative, at conceptually, I am not lying. So these are So this is Lie paradox. Hope you understand this. So what is, in other words, we can say it denies its own truth. All right, guys. Now, next topic is uh, what we say that variables, logical or propositional variables. So let's see what are these logical or propositional variables. Wait a second. I am being. This is not true. Fuck. Logical or propositional variables. Let's see. So logical, which can represent propositions or declarative statements. So variables which can represent variables which can represent uh, which can represent propositions, or we can say declarative statements. Then these are we can say proposition variables. So let's say p is a variable. Then what p is representing? Let's say there is a statement I have time, and q is representing uh, I will submit the assignment. All right. These are declarative statements, and these are variables representing declarative statements. Right. So next is logical operators or connectives. So what are these logical operators or connectives? What are these logical operators? Symbols used to combine or modify logical statements to form more complex statements. So what are these? Let's change the color of the pen. What we should go for? Green? No. Violet? No, no, no. What we should go for? Pink? This is good, I think. Yeah, this is good. Saffron, I think it is. Uh, Symbols used to combine or modify logical statements to form more complex statements. We can, so two or more statements are combined to form more complex statements by logical operators, or we can say connectives also we can say. So what are the types of logical operators or connectives here? Types we can discuss. Types are, one is primary, I think, primary connectives or primary operators, and second is secondary operators. So what are primary operators? For example, one is and. This is logical. I will give proposition also. In proposition we call it conjunction, and we can represent it by this sign, and we can say, and second is or. In logic terms, we can say logical algebra terms. In discrete logical terms, we call it disjunction, conjunction and disjunction, and we represent it with this symbol. And not is also, and we say it negation also, and symbol for this is like that. uh, Caret symbol and tilde symbol. So this called caret symbol, or this is called tilde symbol. All right. And next, for secondary operators. What are secondary operators? Operators which are built with the help of primary operators. Okay. These operators are more complex operators which is built with the help of primary operators only. So first is implication, implication operator. We will learn about this. And second is biconditional, biconditional operator. Third is XOR operator. This symbol of XOR. Fourth is NAND operator. So what we can do is for this, NAND operator is like that. And NAND. This is NAND. We can represent it like, let's say, P and Q and negation for that. So this is also representation. And this is NOR operator also after NAND. So this is NOR, and it can be represented as a, this is negation by the way, P or Q. So yes, hope you understood this thing. And I think our focus time is also 20 minutes have gone. And properties we can, as we discuss, can discuss is properties of these operators we can discuss. Properties also we can discuss. So first property is basic laws. First law is commutative law. All right. So is uh, conjunction or disjunction follow commutative law? I think so. Yes. Conjunction P or Q is equal to Q or P also, and disjunction also follow this commutative law for all powers. So yes, this follow commutative laws, and I think we have 5 minute break. I think so. I will take 5 minute break for this. For that, we will search for it Copilot. We will get the help of AI. I think this is there is no symbol. Uh, let's just check for this. Right. Uh, what what is symbol called for disjunction in logic and discrete math? In 5 minutes break, we can do this only. So, carrot, what this symbol called? So this is not giving me answer correctly. So we will go for Chat GPT here. I think it is more capable than this. All right. P represents distance of proposition of P and Q. Right. P represents it is raining and Q represents. So this is there is no uh, there is no particular name for this. So sorry guys. I should take a break for 5 minutes here. I'm going to drink water. uh, what we are saying now, we will check for other properties for these operators. We will check all operators basically. For first, we are seeing conjunction and disjunctions only. Right. So, let's do this now. Right. Second is commutative, and second is associative law. So I think uh, conjunction and disjunction both follow conjunction, conjunction follow the associative law, and disjunction also follow associative law here. So what we are saying is P and Q and R is equal to, we are not saying equal to holds. We are saying holds and does not holds here. So this showing holds. So this is very important terminology. Uh, P and P, and we are saying because this is similar to that P Q. Wow, no, this is not how it is going. Q and R. All right, and same for disjunction also. Sorry guys. Next we will do is distributive law. So what is distributive law? Distributive law is, there are two types we can discuss here. Is and is distributed over or we are saying is conjunction is distributed over disjunction, or we say is disjunction is distributed over conjunction. Right? So in this they both follow these laws. Uh, Conjunction is distributed over disjunction, and disjunction is also distributed over conjunction. So guys, so next what we do is P and Q and R. So let's say this is an example for this. Let's say is P, so let's so is P, this conjunction is Q or R, is holds for P and Q or P and R. Oh, we understand. P or distribute for Q first, then this, then P is distributed for Q. This is distributed over Q and then R. All right. This is how it works. And oh, this is also similar here. Next is identity. So what is identity here? Identity would be, and for what is the identity? Identity is a value, or we can say a value which does not change the the truth, or we can say original value, original value for that operator. So every operator has its identity value. Different operators have different identity values, but it is unique. Unique for uh, different operators. So let's say what is for conjunction. This is 1 because we are saying is AND. Alright. So AND in logical terms, or we can say is true. So P and true, or we can say 1 is always P. Alright. So this is AND we are saying in terms of logical algebra. Alright. Uh, for next, what we are saying is for disjunction, it would be 0, or we can say OR. So P or 0 is always P, but P or 1 is, we will do this, what we will do is always 1. So we will discuss this in next few minutes. So for OR identity is 0 and for AND identity is 1. Alright, hope you understand this. And complement is what? What is complement? Complement is opposite. We can say A, let's say A is a set, then A complement would be universal set minus A. Alright. Let's say X belongs to A, then uh, A dash if and only if and only if X does not belong to A. Alright. This is how complement works. And what we will do is uh, so how complement works for this P disjunction P dash is always true. Alright. And we can say P and P dash is always false. So how this is? So if P is true, then P complement is false. Alright. So true or false is always true. But true and false is always false. Right? So what is next? Uh, Next would be complement. Uh, some are derived laws also. Those were basic laws, and now these are derived laws. Right? So let's discuss what are derived laws. First is idempotent law. So what is idempotent law is A operator, let's say this is operator A is A only. So what is this? A or A is A only, and A is also A. These are idempotent laws for and or and operator and for or operator. Or we can say conjunction and disjunction. Alright. So self both operands are same. Then what will be the value? that. So same value is same. Absorption loss. Next is absorption law. What is absorption law? So absorption law is A union A dash and B is equal to A or B. So how we can do this? So let me make this clear here. As a note, right? 2 is, this is 3, so we'll make 2. As a note, please write this. This is a note for you. For making logic calculation easy, convert logic into Boolean algebra. This is similar. So what are this is and this is or and this is not. So these are all operators. Alright. So what we will do is here absorption law. If we discuss here uh, A or plus A bar B. So what we can do this is this what we are saying is plus is or is distributive over and. So how we can distribute is like this. A plus A dash and then A plus B. A plus A dash is 1. 1 dot A plus B is always A plus B. Right? So so this is also right. Alright. So next is I think this is stuck here. So right, this is now working properly. Right. Next absorption law is this one is important. Keep focus on this. A or A and B. This is A only. So we can prove this also. If A is true, alright, or this is whatever X, let's say, then true or X always true. So if it is true, then always true. But if A is false, so this cannot decide, this will decide. If A is false here, so A and uh, anything will what we say is false always. So this is false. So decisive entity here is A only. So this is why this is like that. We can say A plus AB. Alright. So this is how it works. This is logical. We cannot prove this by what say uh, truth tables or these Boolean algebraic laws. So we can only do this by uh, A plus A is A, then A plus B is uh, yeah. This is how it does going through, right? So this is absorption law. A A plus B is A only, right? And A and A or B same. If A is true, is also A. Alright. So A is true, then this is also true. True is true and true is always true. But if it is false, then it will make whole thing false. Alright. So this is how it does done. So this is very important to laws. I hope you understand these laws, absorption laws. First is, let me write them cleanly. I think first law is A plus AB is equal to A. We can say A plus B is also A. Alright. In other terms, we can do is A or A and B is A, and A or B is also A. These are both very important laws. Mark it 2 stars, 3 star. We can say 3 star laws, right? Law of double complement. What is next? Double complement. P complement is P. This is double complement law. What is De Morgan's law? Let's understand this. Uh, so can I clear the canvas for simple? Yeah, right. So I'm not mixing my what is De Morgan's law? De Morgan law is uh, we understand it from Boolean algebra only. So A plus complement is H complement dot change the sign, break the line. Okay, break the line, then change the sign, then break the line. We will break the line here. This is breaking the line and change the sign. Change the sign for to opposite of it. So this is how it is. So, and it is also equal to like this, right? First De Morgan law is this. Then this is also one line. We can change the sign. So let's say change the sign, change the sign for this and break the line, break the line. This is how we do it. All right. This is De Morgan's law. And what is domination law? So let's say domination law. Domination law is for which operator what value will dominate on all the values, different values. So let's say it is variable A, proposition variable, and or let's if it is true, then it will always be true. So one, or we can say it is one. So always one. So one is domination value here. For this, for conjunction, 0 is domination value. So always false. So we can say 0. Alright. So these are all basic operators and properties of basic operators. In next lecture, we will discuss drive operators and properties for those drive operators also. So one question also here arises, minimization problem. Minimization problems. These type of problems are asked in GATE exam. So first question would be like this. What is P or Q? And question is P or Q complement. So first we will convert it into Boolean algebra P plus Q. and p plus q bar. Then what we will do is we can what we can do is, let's say it is x, then we can uh, put what we can put distributive law. So x dot p plus x dot q. So what is x? X is p plus q dot p plus p plus q dot q. All right. So what we will do next is p dot p distributing over this plus q dot p, then plus pq q dot q. This is where I say idempotent law. I think idempotent law for this is p only, then pq plus pq. This is q only. I think this was q dash. I think. Oh, sorry. This was q dash, q dash, q dash, p dot q dash, q dash, and this is q dot q dash is put uh, 0 here. So from what, which law? This law was domination law, or we can say not domination law, complement law. This was complement law, right? Complement law. This was 0 only. This is p plus q, p plus q. We can do it like that also, is equal to, we can take common from here p, or we can say like this, p q plus q bar is what? So first is p plus p q plus q bar. This is all complement law. This will become p dot 1, right? And this is identity law. Here it will become p only. Identity law p plus p. This is what? Idempotent law p only. So this is the final minimized version of that, right? Yeah. There could be different ways to do this, but final answer should be unique. So second question is A union B minus C. We will discuss this operator. So B minus C, we can write it differently. So B minus C is what? B minus C is equal, holds forward. X belongs to B minus C is equivalent to X belongs to B, alright, but not both B and C, alright. So how we can do this is uh, so we can do this like that. B minus C is equal to B intersection C complement. So C complement would be what? Universal minus C. So does not belong to C. Does not belong to C. This is C complement, and but belongs to B. Alright. So not C, I think. Belongs to B, but not to C. Not both mean. Not to C. Yeah. Not C and B. Both B and C, I think. That was. Yeah. Both. Alright. So we can do this like that. Now A union B and C complement, and we can change it to Boolean algebra A plus BC bar, and what we can do is we can distribute it like this: A plus B and A plus C bar, right? This is the final answer here. This is the final answer. Thank you so much, guys, for watching this video, and we will meet you in the next one. Thanks so much.